Page 762, number 23. Find the derivative of the function at the specific point. So our function is f of x equals 1 minus x squared, and we're looking at the point x equals 2. So we're going to use the definition of the derivative, and I'm going to use the alternate one, which is simpler for calculations. So the definition that I'm going to use is the limit as h approaches 0 of f of x, this is going to be, we're looking at a point, we'll look at a function in the next example, f of a plus h minus f of a over h. Okay, so in our case, our a is going to be 2, and our h is that very, very small arbitrary distance away from a that we're going to make smaller and smaller so we get to a point where we're just taking the slope at one specific point as close as we can. So h is approaching 0. So substituting in for a, and in our case 2, we're going to get the limit as h approaches 0. So in our function for the first part, we're going to be writing 1 minus and replacing x with 2 plus h. So we're going to have 1 minus 2 plus h squared, and then we are going to subtract from that f of 2, which in our case is going to be 1 minus 2 squared. Oops, I didn't write that very well. 1 minus 2 squared, and then the parentheses that way. And that's all going to be over h. So at this point, it's just going to require a lot of simplifying. So we're going to have the limit as h approaches 0 of 1, and I'm going to expand my first parenthesis. And when I do that, I'm going to have 1 minus, and I want to keep that parenthesis there because I'm going to have to distribute the negative to the entire expansion when I'm done. So I get 4 plus 4h plus h squared. So that is my expansion. And then minus, I'm going to have 1 minus 4. So I have a negative 3. So I'm going to have 1, and I'm going to write it this way. 1 minus 4, and I'll explain why in a minute, why I'm not going to combine those yet, all over h. Okay, so now I'm going to distribute the negative signs. So I have the limit as h approaches 0 of 1 minus 4 minus 4h minus h squared, and then I have a minus 1 and a plus 4, and that's all over h. Now I could have combined those, but what I wanted to point out is at this stage, if you're doing this correctly and the limit does exist, every term that does not have an h should have an opposite signed term to cancel it out, so that all that are left are the terms that have an h in them. So if we did this right, we'll be left with the minus 4h, the minus 4h squared. And it doesn't always, for every function, it's not that you can combine everything and you just have a couple of constants. You'll have different degree variable terms. So I wanted to leave them all separate. So what you can see is I have a positive 1 here that's going to cancel with the minus 1. And I have a minus 4 here, which will cancel with a positive 4. So we do indeed only have our h terms left. So our limit is definitely shrunk. The expression has shrunk. So the limit as h approaches 0 is now negative 4h minus h squared over h. So you're going to be able to get rid of the h again. We're going to be able to divide it out because as h is approaching 0, it's not actually equal to 0. So I'm going to factor it out so you can see what I'm doing here. So I have minus 4 minus h all over h. So these two terms will be able to be divided out, those two factors, and we're left with the limit as h approaches 0 of negative 4 minus h. And now I can see that this will look a lot like h is approaching 0, so it has no effect on the negative 4, so I can think of this as negative 4 minus 0, so I get negative 4. So that's the value of the derivative at the point x equals 2 for this function.